Hello everybody and welcome to the next part of our discussion on sets and stuff. Let's see where we're at. We have introduced sets and combined them with a union and an intersection, and we also looked at a Venn diagrams. There we go, Venn diagrams. And we looked at the union and the intersection and practiced that a little bit by way of questions like exercise 5.2, and there are some problems that are very similar, just to see can we combine these in a more stepwise way and really understand what we're doing. Now, next. Next is to explore the number of elements that a set could have. Now, in our initial examples with the big A, B, C, and D, we could see the elements, the lowercase letters of the alphabet that each set contained. But for bigger collections of things or more complicated situations, that's not going to be the case. We won't know what the elements are. We'll have some information, but it's not going to allow us to know every set's content ever, really. And the question is going to shift from what does the set contain to how many elements does the set contain. Often that's the only question that really is of concern. How big is the set? How many things are in this set? Because remember, from a practical standpoint, we looked at we started problem 5.2. When we create these elements, these results, and place restrictions on them, that's just another way of looking at collections of sets. Okay, so first let's get the language right here. For a set, let's call it E, the number of elements in E is named. Of course, it's a number that is related to the collection of elements that E represents, but it's not E. E is a set. The number of things that are in there will be represented with an E and a line on either side. Now, newer books thought that, ooh, this is too scary, it's too mathy or something. So you might also see in books an N for number of elements and then the set in question. So feel free to use either one. The left one is the actual notation, but people thought that was too scary, so they made it this. I don't see the difference really. So use either one. But please note that is a set, that is a number. For example, if we look at our big A having little a, B, and C, set, number of elements in A, 3. Very big difference. And if you mix them up, I'm going to subtract marks because it shows a lack of understanding. So be very clear when you're talking about a set and when you're talking about the number of elements only in the set. Those things are obviously related, but they are not the same. Very closely related, not the same. Now, let's look at the first special case. Our goal is, in general, to understand that when I combine sets like an A and a B with a union, how does the number of elements change? Okay. So the first special case is if they have no elements in common. The intersection is empty. Then I can because I have this extra information, I can visualize it as follows with a Venn diagram. I now have extra information that I can use to make my Venn diagram look simpler, only in this special case. And say that, well, they have no overlap, excuse me, so they can be drawn separately and visualized separately. Then we can say, well, if I merge these two by way of a union, I can literally count everything that is in A, everything that is in B, and I'll simply add them up, and that will give me the total. No problem. Easy. But in general, we won't know if they have no overlap, and we have to be ready for the fact that there is an overlap. So see what would happen then. In general, A intersection, A and B may overlap. So then the Venn diagram has to be the general position, right? There. General position. Sets. Let's call them A and B. I don't know what they are specifically. They could be. Will look like this. Now I want to know how can I figure out the number of elements in the union based on the individual numbers? Well, I do want it to look similar to what I had before. And let's see what we get at this stage. Let's use some colors. If we stop here, let's see how close are we. Let's go pink. Now A consists of two regions. It consists of the pink region. In here, two regions. We have the pink region, pinky, and a part of A is also this overlap section here. Let's make it purple. That looks pretty good. Purple. There we go. And so any elements in pink and any elements that are purple will be counted when I consider the number of elements in A. Okay. When I consider the number of elements in B, I'm also going to count the purple. I count these purples again. And I'm also counting this other section of B. A lot of colors switching. Let's make it blue. And I'm also counting some blues. Now, in my counting, I'll just say it by way of the book here. Speed things up a little bit. In my counting goal, Ooh, it's very slow. There we go. In my counting goal, any counting problem, I have the following two check boxes that I must make sure are satisfied. I have to make sure I don't miss anything. Let's do it over there. I don't know where. Up here somewhere. Nope, let's do it over there. I have to make sure I don't miss anything and that I do count everything that must be counted. Just do. Oh, I want to drag fire. Am I doing that? Well, yes, because when I consider A union B, it is colored when I throw everything together. Everything has a color. Everything is considered. So I'm certainly counting everything that should be counted. I'm not missing out on anything. Good. That's the first goal. But the second one, I also have to count everything exactly once, or my number won't be correct. The number that I get at the end won't be right. If I count something double, then my number is going to be much bigger than it should be. And that's exactly what's happening here. When I consider A, I'm counting all the pink stuff and all the purple stuff. When I'm considering B, I'm counting the purple stuff again and the blue stuff for the first time. So the purple stuff, those are counted twice. So my number's not right. Now I can fix this by just taking away the purple stuff. Because I counted it twice, taking it away once will balance everything out. And the purple stuff is exactly the intersection. So there I have a relationship between the number of elements in the union, the individual sets, and the intersection. And now this isn't crucial to memorize. I think it's handy because it comes up every now and then. Whenever you think it's not going to come up, it probably is. But there's always a way around it, as we'll see soon enough. It's just handy. It does speed things up eventually. And it's a good exercise to just uh, make sure you understand unions and intersections. Again, Venn diagrams. So it's just a good practice to understand where this comes from because of this overcounting problem, because the overlap is in both. Okay. So memorize this if you want to, or don't. I don't really know. I do because every now and then it's handy, but it's certainly not crucial that you do. It's totally for our level of problems. There's always a way around it, but that way is probably going to be longer. I will leave it up to you. Now, let's get to our problems here. Let's get to the fun stuff where we have some information about a problem. Wow, look how slow that is. It's so slow. So slow. There we go. Just want to get to my exercise here. So we'll be okay. Okay, let's see this exercise. Jack and Jill have 10 school projects to do. Jack is involved in 5 of the projects, and they do 3 projects together. How many projects is Jill involved in? So see, the question is how many, the number of projects that Jill is involved in. Now, admittedly, this question is super simple, and you can just figure it out probably on your own in a few seconds. However, I like to pick a question that we can verify the answer. Now let's pretend it's more complicated and see how sets can be used to answer this so that when it does get more complicated and I don't know the answer, I can fall back on my sets and systematic method to do it. So the first question is definitely It's going to be overkill to do it this way, but I'm building up to the ones where I don't kind of have a choice. So now, if you're watching the video after the fact, it is definitely good to pause and make sure that you understand the question before. In the interest of saving time, in a live session, never do that. We just read it once and then you're expected to remember. That's totally fair. So if you're not sure what the question is saying, watch it again later or pause it right now. Read it again. Read it 5 times. We have to always understand the question first and the information that they're giving. Not how I'm going to use it, not what I'm going to do, just understand what the question is saying. So I am going to define some sets. Now my sets don't have names, so I'm going to give them names. I'm going to let A represent the projects that Jack is involved in. And B is going to represent the projects or the collection of projects that Jill is involved in. It's very important to understand what your sets represent. You cannot say, let A represent Jack. A is not a person. A is a set. A is a collection of projects. You cannot say, let A represent the number of projects that Jack is involved in. A is not a number. A is a set. A is a collection of projects. You say it any other way, you're going to lose a mark. I'm going to reserve a mark to see who understands what their sets represent. And if you're lazy, if you're sloppy, if you say A is Jack, you're not getting your mark. You have to earn it. It's as simple as that. So I am now forever on the video saying this. Anyone complaining when I deduct marks, I will refer to this point in this video. Now, we have two sets because there are only two things. Let's make a Venn diagram because visualizing these things makes it easier. Two sets, general position, because I don't know what specifically they contain. And I don't really care at this point either. There's no downside in putting it in a general position. So this then shows there could be some projects that I don't even know about. There could be some projects that Jack does on his own, Jill does on her own, and some projects they do together. So now let's read the information. Because it's our first one, I'll show you the information. It's just my screens have different resolutions. So if I move it back and forth, I have to zoom out and in every time. Otherwise, I can't see the chat. Jack and Jill have 10 school projects to do. 10 school projects to do. That means if I pool all of their projects together, I'll get 10. Now, I'm not going to put the 10 there, or there, or there, or there, because it's a collection of more than one region. And I'm going to forget what that 10 represents. So I'll just put it on the side because they're giving me information about the union. However, I have a diagram here. It would be nice to put things on the diagram when I can. It says here, Jack is involved in 5 of the projects. Again here, I don't want to put the 5 there because in a bigger question, which is what I'm trying to set up, I'm going to forget what that 5 represents. I'm going to maybe later down the line, many things happen. I come back to this diagram. Is 5 only the projects he's involved in on his own? Or is it his total number of projects? I have no idea. So there is a risk in putting a number in when it represents multiple regions. Risk is so great, I will never do it. Because they only say Jack is involved in 5 of the projects. That means he is involved in 5 of the projects. On his own or with Jill, he's doing a total of 5 projects. It's not a single region. I'm not going to put it in because there is a serious risk of misinterpreting that 5 later on in a bigger question. And then they say they do 3 projects together. Now that is only this guy. I don't want to get too mixed up, not mixed up, all cluttered up here. If I have a choice and the opportunity to put a number in, I'm going to put it. And because this 3 represents only the projects they do together, there is no downside to putting it in. It's equivalent to writing the intersection is 3. But because I already have it in, I don't need to double up on the information. It just needs to be somewhere out of the paragraph that they give me. Like there, 3. Now that 3 unlocks some other regions, single regions. Because the A circle is 5 and has 5 in total. No, not 5, but 2. And I'm done with that information. It is in there now. I don't have to double up on it. Because the A and the B circles together contain 10, the single region contains 5. I'm done with that information as well. I just, at that stage, I couldn't quite put it in. I needed the 3 to unlock it. Now, they don't give me the total school projects that the class does, so I don't know how many are outside. I don't care. The question doesn't ask that. The question asks, how many projects is Jill involved in? So now I can say, maybe with color, maybe pink. We're looking for this region or regions. Projects that Jill is involved in, not necessarily on her own. This guy, right? These 2 regions. And then we can say, let's say here, our final sentence is fine at this stage. We can say Jill is involved in 8 projects. Done. Now I know it's completely overkill in this case. Absolutely. It wasn't hard to figure out the 8. Perhaps. Or maybe it was. But soon it's not going to be easy. And I need some structure. I need a systematic way to work my way through the problem. This is how I'm going to do it. Let's write down how I'm going to do this. Follow this. Don't follow this. You're in control of your own destiny. But I have seen many times anyone who does not follow these steps will have a high chance of making a mistake at some point. I've seen it many times. So I prefer to be wise and learn from others' mistakes. So here, first thing to do, give names and clearly define your sets. What you're going to use, you can name it whatever you want, but say clearly what they mean. Then we want to set up our Venn diagram with as many circles as we have sets. It's convenient, but not too many. General position, I think almost always. It's going to have to be a very special question for me to not go general position. I'll make a statement. I'll always go general position. And if it turns out there's no overlap, I'll put a 0 in there or whatever information they give me. There's no harm in having a region with a 0 in. I'd rather be safe. Then I want to, let's say, extract information. Ideally, I want to put it in the Venn diagram, put numbers in the Venn diagram because it's going to make things so much easier. However, capitalize that one. Only put a number in the Venn diagram if it represents a single region. You know, it's funny in a sad way. I do this every time. I write it out. Other courses, I do the same thing whenever this topic comes up. And there's always someone, always, whether I know it or not, it turns out they're always there. Someone who thinks, I know what I'm doing. I don't need to listen to him. I'm good. And then they don't follow this step, this little arrow step. They put the numbers wherever they want, and it is 100% that they will make a mistake somewhere in the semester. Every single time it happens. You decide if you want to be that person and roll the dice. I don't. Okay, so that's my safety. And if there's information, I do want to get it out. I do. If it's not ready to be put in the Venn diagram, I'll write it on the side. Maybe later I can, but it does happen sometimes. And then not lastly, almost, I want to identify the region or regions that the question wants. Or just question me to find. Say it like that. And then find it. Find the number. It's a little vague at the end here because it depends on what the question is asking me, depends on what the question is giving me, all kinds of things we'll see. Can get a little complicated. But the first three steps, hopefully, as much as they can, set me up for success. Again, I might have a ton of experience, a lot of skill and insight for how to visualize these things in my head, and I don't need the steps. They give me a higher chance of success when things get complicated, when I need them. But in a test, we have to show our work anyway, so we kind of stuck with showing something. Can't just show the answer. So all these things are in the book as well. Read it. It is the same thing. Let's do our first basic three-set question. This is sort of the basic one. Must master this at all costs to build. This is big enough. Bigger. Bad? All right, let's do this thing. Now, I also, before I start reading, I want to, I want you to just be aware. How obvious are things from reading this through once? An elementary school is offering three language classes, one in Spanish, one in French, one in German. These classes are open to any of the 100 students in the school. There are 28 students in Spanish, 26 in French, 16 in German. There are 12 students that are in both Spanish and French, 4 that are in both Spanish and German, 6 that are in both French and German. There are 3 students taking all 3 classes. And then they ask me some stuff I actually don't really care right now because I only care about what they're asking in step 4. So until I'm at step 4, I don't even read it. It won't affect steps 1, 2, and 3. However, I do realize that reading through this once, I have no idea. It's not enough. I need to read through this multiple times, work my way through and extract the information slowly to know what I have to work with, and that's okay. The first step is only the first step. Figure out what my sets will be. Hopefully, people have noticed, if nothing else, there are three languages in question. I'm going to need three sets. What's this? There's the 5.4. Let, I guess, what's the first language? Spanish. Let S represent Spanish. No, S is not a language. S is a collection of students taking Spanish. Collection, set, same word. The set of students taking Spanish. Every time people are so lazy and don't want to write out a full, clear explanation of what their set represents. This time, I'm going to be super strict. I am tired of this laziness. People do it every time. They take advantage of me. It needs to be super clear to confirm you understand what your sets represent. Not a full sentence. You're not getting your mark. Simple. French, I'll go F to represent. It takes like seconds to write these sentences. The set of students taking. Ooh, that's ugly. I'll still accept it. French. And G. Rep. Whoa, seriously, that's too much. Dent. Set of taking. All right. Now, step 2 says Venn diagram. General position, obviously for 3 sets. Go. S over here, F over there, G over there. I don't write words in my Venn diagram. They're separate. Symbols as letters, for example. All right. So the meaning of these sets aren't overly complicated. I have them in general position because I don't know what their overlaps are. Now, my next goal is to get information out. But there's no rule saying I have to do it from the top to the bottom. I want to put as much in my Venn diagram as possible as long as I get everything out eventually. They start by saying it's open to any of the 100 students in the class. So there are 100 students over here. I'll do it. 100 students in the rectangle, in the school. The school, my rectangle. Now, they tell me there are 28 students in the Spanish class. But at this stage, the Spanish circle, rather, consists of different regions. So I can't put the 28 in. Well, I can. I really shouldn't put the 28 in there because I'm going to forget what that 28 represents. That's my choice, my rule, keeping me safe. I can write it on the side here, but let's just see if maybe later on I can come back and get this in. I don't have to write anything right now as long as eventually all the information is out. 26 students in the French class, same problem, right? French consists of 4 regions right now, so I can't put it in safely. See, German, same problem. There are 12 students that are in both Spanish and French. Now, Spanish and French is the overlap here, but that consists of these 2 regions. Can't put it in. I want to. Not 4 that are in both Spanish and German. Spanish and German, 2 regions. Same for the 6. There are 3 students taking all 3 classes. Ooh, hello. That's only this region. I can put it in. Now I realize, I hope, I can work backwards and unlock the other regions. Let's read backwards. Well, not fully backwards, but sort of. There are 6 that are in both French and German class. 6, both French and German. But now I have one of those regions, so the other one's a 3. Well, as long as I, in whatever direction, get all the information out, I'm good. It doesn't have to be from start to finish. This time it's backwards. Sometimes it's forwards. It depends on how the paragraph is phrased. It is very much a puzzle, yes. And I'm trying to set things up to make the puzzle as easy as possible. And visualizing it's definitely going to help. Now keep working backwards. 4 that are in both Spanish and German. Spanish, German overlap between those two. 4 in total. I have one region, so this one's a 1. Then I have 12 that are in both Spanish and French. 12 over here. 3 are already there. 9 there. Keep working backwards here in my question. 16 in the German class. 16 in the German class. Now I have 3 of the 4 regions. The whole circle has to add up to 16. I already have 7, so 9. But I couldn't do it at the start. I had to sort of get to the end and then see how it unlocks regions. 26 in the French class, 26 in total in this circle. I already have 15, so it looks like 11. And then 28 Spanish class, 28 I said. I already have 13, so that looks like a 15. There is another region. The outside is also a region, and it might be necessary, it might not be, but if I could figure out every single region in my Venn diagram, there is literally nothing they could ask that is going to be. I might as well do that now. I have 100 in the rectangle. If I take away all these numbers that I see, that is going to give me the outside. Let's give MathBot something to do. And then we can see it as well. So 100 minus 15 minus 9 minus 1 minus 3 minus 3 minus 9. MathBot says 49. Now I know I could have left it and see if it was even necessary in a question that comes, but I might as well finish it now. It is a region that I may need. Now they ask some stuff. How many students are taking one or more language classes? So now I don't want to really have too much color on here. Maybe we will maybe just put circles around the numbers. Maybe pink. How many students? What? One or more language classes. So not the 15, because those are the people that are only taking Spanish. Yes, the 49 is the complement of the union of all of this, but visualizing it is much easier than writing it in terms of the sets. There's no need for that puzzle solving aspect. One or more will be these guys. Could be, what? Maybe I should read the question. I did this on purpose. Make sure we read the question, right? How many students are taking one or more? So one is okay, or more. So these are okay. One, maybe two, all three. So these are all okay. Oh, good. So then I could say here, number of students taking one or more is going to be 15 plus 9 plus 11 plus 1 plus 3 plus 9, we already know it's 51 based on what we've done here. But it's good to show some detail and show how it's coming from your Venn diagram. So in case you have this 11 because of some arithmetic problem, you accidentally wrote a 12, you're still showing that you're using the Venn diagram correctly. If there's a mistake in the Venn diagram, that's one mistake. But if you're then using that correctly, then it's correct. No, let's not think again. B. B is asking, excuse me, how many students are not taking any language classes? How many students are not taking any language classes? That's the 49. I'm going to just save time. Do not fill in the words here, but I want to get to that last question. Weekend comes up. So don't answer a test like this. Fill in the words there yourself, but you're copying the question, right? That can't be that. I've my. I need the ability to click. There it is. How many students are in exactly one language class? Exactly one language class. Only because I really want to get that last one in to give you all the information you have going into the weekend. So I have 24, 35. Okay, so once I have all the numbers, I can answer anything they want, right? Please write it out. I don't want to set a bad example here, but I want the last one. It's otherwise you can't practice everything. My mouse is unhappy. Ah, got it. Okay, get you all the information, and then you work on those problems. And if we finish now, we'll have 2 Q&A sessions next week, Monday and Tuesday. Okay, let's do this thing. 7 minutes, easy, easy. A certain school has 200 students. Of these students, 90 are enrolled in a psychology course, 100 in an engineering course, 70 are enrolled in an economics course. Exactly 30 students are enrolled in both psychology and economics. 20 are enrolled in courses from all 3 subjects. Lastly, 50 out of the 200 students are enrolled only in engineering. They ask some stuff. I'm not ready for that stuff. I want to set it up first. You know, I just looked at the number. I don't remember the number. Okay, so we again have 3 subjects here, so that's going to be very similar. Let P for psychology. Lower my computer. P represent the set, I'm not taking a shortcut here, set of students taking psychology. Now, I don't want to say engineering because E is in economics as well. So let's use the second, N for engineering, C for economics. Let N represent the set of students taking engineering, and let C represent the set of students taking economics. Even though I'm in a hurry, well, not really, I think we're good, but a little bit of a hurry. I'm still writing out my sentences. I'm cashing in, not cashing in, I'm banking that 1 mark for this first step. Let me visualize. Universal set. Let's put P over there, N over there, C over there. Why not? All right. Now let me move up. We know what P, N, and C mean. Now my goal is to get all this information out. Well, 200 students. Okay, that's not bad. I don't know why I said that. Now, it might be shuffled around. I still go from the start to see what's the first thing I can put in. 90 are enrolled in psychology. I know I can't put that in. I have 4 regions right now for psychology, all open, all waiting for numbers. It's okay. 100 in engineering, same problem. 70 in economics, same problem. 30 students are enrolled in both the psychology and economics course. Psychology, economics. Still 2. I want getting closer. It's not working. Not ready to be put in. 20 are enrolled courses from all 3 subjects. That is something I can put in. 20, all 3 subjects. Okay. I'll keep going. Lastly, 50 out of the 200 students are enrolled only in engineering. Only in engineering. Yeah, I can put that in, sure. That's exactly this one region. Sweet. Is there anything that is unlocked? I'm pretty sure this 30 is unlocking a region. 30 students are enrolled in both psychology and economics. Psychology, economics, 30. Well, I have the 20 of these 2 regions, so that one has to be a 10. So now I'm going a little faster than for sure. I have to make sure I get all the information out. If I can't put it in the Venn diagram, I still want it out, or I'm going to forget about it, and it might be crucial. I have the 200, so if I could write on this, I could check that off. I don't have the 90. I don't have the 100. I don't have the 70. The 30 unlocked one region. 20 was at the center. The 50 was in there as well. So these 3 I don't have. 90 are enrolled in psychology. I still have 2 missing regions of psychology. So now I'm going to just put it on the side there. I can't put it in. Okay. As long as I'm aware that it's information I might need. 100 in the engineering course. Missing regions for the N circle. Close, but nope. Economics. 2 regions. Man, this one's a little bit more difficult in that, unlike the previous situation, which was sort of my basic question, I can't put everything in. That's always the ideal, but based on how they give me the information, it's just not going to happen. If I follow my rule, which I'm always going to follow, it's just not going to happen. Can't put everything in. But I have everything on my page extracted from the question. That's the best I can do. That's okay. Now, the steps say I did number 3. I extracted as much as I can into the Venn diagram. Find the region that the question wants. Make it pink. Region or regions, I don't know yet, that we want. Pink. Color is so nice. Okay. Now they say determine the number of students enrolled in courses from at least 2 of the 3 subjects. At least 2 means 2 or more. At least 2 subjects. Now these pieces over here are only 1. At least 2. Yeah, that'll be 2. So definitely this one. These 2. Yeah, this will be economics and engineering. This will be good as well. Don't want to cover the number. And all 3 will be the more, 2 or more. It's all flower situation. Okay, back to black. Very close. Oh, the question's done. Now how do I do it? In the more complicated situations, it is not as simple as it is here, where I just pick my regions and add up the numbers I see. Unfortunately not. Yes, I can add the 10 and the 20, but there are two missing regions I don't know. And in fact, I cannot know what numbers are in those regions individually. It is literally impossible. And I can't guess. But we want we want only the total number of students in the pink regions. That's the only thing the question is at. Determine the number of students, at least two subjects. Not individually, that's not the question. The question is how many people are in the pink regions? And I have a lot of information about this n circle. That in total, the n circle is 100. There's 50 of them, there's 20 of them. So together, say here, together, these two question mark regions must be 30 because that's what's missing to make 100. 70 are accounted for, regions are missing, to make 100 has to be 30. So the, let's just say here, the answer, they're only asking one question, for the number of students is my 10 plus my 20 that are visible, and then the combined number for these question mark regions will be 30 to give me a total of 60. So 60 students are taking at least oof, two subjects rather. Right. So very important lesson. I didn't want to skip it because it's going to happen in the problems that are more difficult. Don't think everything is like this. Some of them are, and that's certainly the ideal, where I just pick the regions and add up the numbers. Perfect, easy. Not always. But that's also not what is being asked sometimes. They only want the total. Once I identify the regions, what's the total number in those regions? Puzzle aspect is how can I figure out that total? How can I figure out what they are asking? They give me information to answer their question, not necessarily any other question. For example, I will never know what is in here. How many students are just taking psychology? It's impossible to know because of the information that I'm being given. But that's also not the question. Focus on the question and how to use the information to answer that question. There's a lot. There's a lot to do here. I'm not going to lie. But we kind of need it. This topic, it's important. You'll see some of them are straightforward, where I have numbers for every region. I those. But then some of them are less, and do them in order. They're in increasing difficulty as them. And you'll see that it's a puzzle. And I just have to combine all the things that I've seen so far, my steps to keep me safe, and all of that. And hopefully we can make some progress. But now that we've squeezed everything in today, we'll have Monday and Tuesday. Come prepared though. Don't sit back and say, oh, can you do problem 5.9 for me? I've never looked at it, but can you just do it? Of course I can, but it'll mean nothing to you for development and preparation for a test. Don't ask something that you have not spent significant time on. That's how you get the most out of it. It's going to take time. It is. Don't shy away from that. It'll be beneficial. All right. Any last questions, words of wisdom as we head into our struggle time? It's a good struggle. You have to be okay with the struggle. It's part of the process. I I don't know what else. Make you better. And you look back like, oh, why did I ever struggle with this? It was so easy. Well, yeah, perspective makes all the difference, right? So I apologize for going over the time, but in the grand scheme of things, I think it was the right thing to do. Watch the video again over and over and over. That's why they're there. Why they're there. Make sure of these questions that we've done before tackling any problem. Make sure about the exercises first. All right, I'll stop rambling. See you maybe next time, maybe in a Q&A session, maybe not. Use it as you need to use it.